All right. Let's start today's lecture. So yeah, as I mentioned yesterday, turn off this. I have uploaded assignments yesterday, and yeah, I mean, I hope you have already got started. Yeah, since we talked about assignment, so yeah, the due date is Friday 23:59. So it's Friday night. um, I hope you don't stay up too late for this assignment. So yeah, so just try to start as early as you want. And then we have question one. Question one is about this is a classical one. Find out if a given number is a prime number, and then you can have those input and output, like those sample input and output, right? And then this is something that you probably needs to use the square root function, mass dot square root. If you provide it for, then you just get square root, and then you just put your code here. And then, yeah, for question two, you're given this string of item prices. So it's like BMW, blah, 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 Audi, blah, 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 Xbox, PS5. I think you guys will like this. But yeah, convert them into dictionary. All right. So this is originally a string, and try to manipulate them somehow to make it into a dictionary. Okay, so yeah, I didn't write the output, but like I'll just look through your code and see if that is a dictionary, and then for it, you check yourself. You can just do type, right? Type something, and then that will print out if it's a dictionary or not. All right, so question three is about leap year. The idea of leap year is, if this is a comment about leap year. So not every 4 year is a leap year. The rule is that if the year is divisible by, yeah, I'm just admitting one person. Yeah, if the year is divisible by 100 and not by 400, and leap year is skipped. Okay, and the year 2000 was a leap year, for example, but the years 1700, 1800, and 1900 were not. Next time a leap year will be skipped is 2100. So yeah, because our range is um 1900 and 2100. There are two answers that have been already revealed. Okay, so what will happen is like this. So you print out 1900 and then blah blah blah, and then once you have a leap year, then you just print leap year. Okay, and then you just continue blah blah blah, and then 2000 is also a leap year, and then blah 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 until all the way until 2000 and 100. Okay. Yeah, question four. Question four is like you are given a point x and y in the plane, and you need to figure out which quadrant it is, or maybe on the axis. And then I have this input and output. So like if the coordinates, oh yeah, the first one always means x, and the second one always means y. That is assumed. That is assumed in this question. So yeah, you have output here as well. So this will be first quadrant. 0, 0 will be origin, x-axis, y-axis. This is fourth quadrant, third quadrant, second quadrant. Okay, so yeah, so you just put your code here. And question five, given a binary number and calculate its value in decimal. So I am not sure if you all know binary. This input looks really crazy, but you can actually deal with it. All right. Yeah. So given how do we calculate a binary number? So 101 in binary. So we just start from the right. The first one means 2 to the power of 0. The second one means 2 to the power of 1. And the third one is 2 to the power of 2. Okay, and then you just use the digit on every bit and multiply by the value of each position. And that gives you 5. And this is pretty much the same. So 0 times 2 to the 0 is this one. 1 times 2 to the 1 is this one, right? And then so on and so forth. After you calculate it, then you'll get number 18, okay? And then the reason I make such number is that, yeah, I don't hope that you just do it by hand. I hope that you actually write some program to calculate those. All right, so yeah, that's and yeah, here's the code box for question 5. So yeah, that is the 5 questions in for assignment 1. And I don't know, in terms of time commitment, um I am not very sure how long will this take. I would say maybe 2 hours is a reasonable amount, right? Obviously, some of you might like spend less time if you studied it pretty well, or you just understand those questions. Maybe some of you needs more time than 2 hours. Maybe it could be range from 3 to 4 hours. But yeah, some of the question, it doesn't really require you 1 hour, right? You just go through the exercises that we are done in the class, or that I take up in the class. Then you can find some hints there as well. Okay, so that is in terms of assignment. And yeah, since we're done with the assignment review, we are going to talk very shortly about dictionary. Okay. Oh yeah, that is just a brief review of yesterday. So yeah, dictionary means that you have a key value pair. You can put in the key value pair in there, and then using this notation. Okay, and then you can also use a tuple as a um, key to the dictionary, but like it is not really required. Um, and then here you can also use a list of tuple and then pass into this function dict, and then you just pass it in there, and then it will return a dictionary. Okay, yeah. Also, today we are going to talk about function. So yeah, I'm just gonna elaborate a little bit more on that. Yeah, so you can have a list of lists, and then you can just do dict4. Dict4 is equal to dict, and then bracket cars, and then it just pass in that list and then print it out. Okay, you can construct it as an empty list as well, empty dictionary as well. And then you can also use some fashion like this. So you just specify the key, and then you do equal to something. Okay. So basic usage of dictionary. So index or slash key. Yeah, I mean the index for the dictionary will just be key, right? So yeah, the key is the key to everything, pun intended. Yeah, so you can use the key and then access the value in the dictionary. So here, so scores Chinese, and then it just returns 89, and then you print scores, and then if the item is not in there yet, you can use this fashion to add a key value pair. So in this case, for example, mass is equal to 93 and then 19 is equal to 91. Okay, but yeah, so you can also delete that entry. So if you do delete scores, mass, and then the entire key value pair is key key value pair is deleted. Okay, and then yeah, so you can also change. You can also change the value of a specific key, right? So it is just the same way to do it. I'm just not going to repeat myself. Um, you can have this in operator. So you can check a key if a key is in cars, right? So this dictionary. So yeah, method for dictionary. You can use this method called dir, and then you just pass in this class dictionary, and then you can find out all those classes in it. And then yeah, we can talk more upon like what does each of those class do. But yeah, it was a later problem. It is when we actually talk about like class or class and stuff like object oriented. We are definitely going to talk about this. So yeah, the clear function, cars.clear, just calls this function, and then every entry in the cars are deleted. Okay, the get. So the only difference between get and square bracket notation is that when you do square bracket on a on existing key, then it will give you a key arrow. Well, while if you do use get, then it will just return you a none. Okay, yeah, so update means you're taking another dictionary and update existing dictionary. And then if there is repeated values, then the value will be changed. If certain item is not in the current dictionary, then that item will be added, right? So this here, Ferrari is equal to 9.5, and is added into this cars. Okay, so yeah, there's functions called items, keys, and values. Items are just basically a key value pair, and then yeah, and then keys are just those keys. Values are just those values. They basically works the same. uh, yeah, and then also the function called pop. It basically does the same thing as delete. I'm not sure very deep in there is there any difference, but it seems that there is no difference between like pop Aldi or delete cars square bracket um, Aldi, right? So on the fact that both entries are deleted, right? And then you can also use a dictionary for the input of the string, right? So you can have this percent bracket name, and then price is blah blah blah, and then you just pass in um, the values like this. Okay, so yeah, in terms of exercise, I have talked about it yesterday. Yeah, so more program flow control. So yeah, pass is just a keyword and a placeholder, so that you just um, pass through this condition. And then assert means if you have a certain condition that you want to meet, or you want to specify the users from this input to that input, right? So like you're basically giving out a range, and you're saying, make sure age is less than 10, and larger than 10 and less than 80. Okay. And yeah, I forgot to mention here, so in terms of this, in most language, um, we only support one, like when you do larger than or less, larger than, like those comparisons, most language only support something like this, right? So you'll have to do it on two separate sentences, and you just do and to connect it. But yeah, Python can do that. So that is a good feature about it. But yeah, if you want to really make yourself clear and avoid any sort of ambiguity, then you can use this notation, and that is basically the same as this. Okay. And then yeah, if the assertion is failed, let me show you. Then it will give you an assertion fail arrow. For example, my age is 1. And then yeah, there is a assertion arrow which tells you which assert that fails. Then you can specifically fix that, or the user will know what happens. Okay, so that is assert. Use loop to iterate through a dictionary. How do we do that? We can have this for in loop, and then you if you want to iterate on this items, then you can do like two variables here, right? This is sort of like unpacking the tuple, right? So you have a sort of a tuple of items, which is like key and value, and then it is like for key comma value, and then it just unpacks from that tuple, and then takes out the value in each one of them. So yeah, you can get key is key, val is val, and then iterate every time. Okay. So yeah, if you only want to iterate keys, you can do this. If you only want to iterate values, you can do this as well. So yeah, that is, oh yeah, check how many times an element appears in the list. It is basically saying, it is basically the idea that you construct a dictionary, and then once you've seen, like, and then it iterates through the list, right? And then if you've seen an element that is not in the dictionary yet, add to it, right? And if you've seen it, just add one, add like one on its value, right? So that it indicates how many times it appears. Okay, so yeah, that is counting. Nested loops. Nested loops is my favorite, or not gonna say my favorite, but you will definitely need to deal with it a lot in your life, in your programming life. Okay, so nested loops. It is basically like loop in a loop, right? You don't continue the next iteration of outer loop before you finish the inner loop, right? So for example, I is equal to 0, and then j is equal to 0 to 9, right? It has to operating from 0 to 9 before I is incremented. Okay, and then yeah, be aware of the indentation, because like I haven't seen you guys coding a lot, so I'm not sure if there is any other kind of problems that need to be fixed. But like yeah, indentation is really important. If you just try to like delete this and then you try to run it, it will not work. So it will actually tell you expected and indentation work. And then if you don't align this print the same as this here, the same as this for loop. If you do indent here, then for every, yeah, in this case, for every 0, it will give you a next line, which is not what I want. What I want is after the inner loop, I will print a line break so that, I can tell that, yeah, this 10 zeros are done. So I just print, do a little bit enter so that to indicate this row is done. Okay, so yeah, that is that. One line for loop, you can do it on one line, but for sure you can do it on like different lines. But like, sometimes programmers are lazy. Sometimes it is just that easy when you get used to Python a lot. So yeah, that is one line for loop. A range is equal to range 10, and then x times x for x, right? So this is sort of the index, or the feeling of one line stuff. So you are doing something with it, and what is that something? The something is for each x in this range, right? Yeah, so for example, in this A range, it is 10, then it is basically from 0 to 9, right? And then you have the x from 0 to 9, and then you're just doing x times x, right? So x times x, 0 times 0 is 0, 1 times 1 is, yeah, so you're just outputting the perfect squares of from 0 to 10. Okay, and then you can also have a condition here if x percentage by 2 is equal to 0. Yeah, and then it is basically saying that you do x times x only if x divided percentage by 2 is equal to 0, else do nothing, right? So yeah, that is the idea. Or if you want to be creative, else x plus x, and then okay, invalid syntax, so ignore that. Yeah, don't worry about it. Okay, that is that. So yeah, write a program to combine two different dictionary. We have talked about it yesterday. So it just sort of have a another dictionary, and you try to update a. Okay, and then list 8 keys. It just gets you all the keys, and then those are the condition. And then this exercise actually becomes a assignment problem. So I am not gonna talk too much about it. Yeah, so I will let you guys figure out. Yeah, so in terms of this question, I will make a comment, especially. So there is different ways to do it, and some ways it is more efficient than the other. And I right now, because we have not learned anything about algorithm analysis, so I am not gonna make a requirement of like how fast it needs to be. But this can give you some introduction to this optimization. So like, how long do you need to check for a prime number? So I will just say this. Yeah, and then the rest of it, you can try to think about it yourself, and then try to give it out a solution. And sometimes it is not most optimized. It's okay. You can have your solution working, and then try to optimize it. All right. So that is a brief review of yesterday and the assignment. So yeah, today's lecture we are going to talk about function. Um, so what does a function mean? We have seen quite a lot of function, right? And then a function just means that a piece of code. Yeah, I define it myself. You don't have to be really stick to this definition, but it is just there for you to know, because programming is not about like those knowledge, right? It is about how you write your code. Um, and the only time you need those kind of knowledge is during an interview. But it is not the purpose of this course. This is not interview preparation course. All right, so yeah, this purpose is just teach you guys how to code. Okay, so briefly, it means a piece of code that does a specific thing, right? What does that mean? So, for example, the lens function, right? We are using lens function by quite a bit. And then the lens function, if you pass in a string, then it will just tell you how long the string is, right? If you pass in a list, then it will tell you how long the list is, right? So yeah, it deals with all those situations and actually perform a task. This task is just um, return the string, the length of that specific object that you passed in, right? So that is len, and then you can have max as well, and then the max function of a list, it just gives out the largest number slash string in that list, and then if you have a string, then it just gives out the largest character in ASCII table, right? And then yeah, so it is basically the idea that you pass in the parameters to a function, and you just think of a function as a black box. It performs a thing, and then you don't really have to know how it works, as long as you know what will be the output of this function, right? Like in terms of length function, you don't actually know what is going in there, right? Until you actually go to read the source code of the function definition of length, right? And then, I mean, not a lot of people have read this source code for a lens, right? And then we are not required to read it, right? Because those libraries or those functions are already there to perform a task. You don't really need to know like how the task is done, right? Sometimes you only need to know the outcome is, right? So like for example, you're assigning some task, right? Like assigning some task to another person, right? And then sometimes you don't want to know the details about like how they do, right? How much trouble they overcome to those tasks. Like the only thing you do know is that sometimes what's the outcome of this task, right? Since sometimes it is not all true for all the cases, but this is just analogy, right? So just keep you guys, more like well understand it to what is a function. Okay, so yeah, syntax for a function, defining a function in Python is that you have this I don't know keyword, which is def, which is def, and then you have the function name, right? And then after that, the function name is just how you call this function. For example, len have the function name len, right? So that is self-explanatory. Um, in terms of parameters, um, the brackets, the parameters in this bracket is called formal parameters. Okay, and I'm gonna explain later about what does that mean. So so far you only need to know that in the bracket here is parameters, and you know, you can specify how much parameter or what the parameters are. Okay, so yeah, we were gonna learn that later in this lecture. And then so you perform a certain task. I don't know what the task is. It can be print, it can be, you know, addition, multiplication, or whatever task you want to be. And then you can have a return value, or you cannot. And the idea of return value is that once you call a function, do you expect it to return something? What does that mean exactly? So you would expect the length of, for example, a string called ray is 3, right? So that is a return value. But you know, sometimes the function does not return anything, and yeah, sometimes, yeah. So in terms of that, we will come into like more detailed examples using those. But yeah, so it can return nothing. In other language, it is called void. So like you don't have to return anything. So as long as you do the thing there, you're good. Okay, so like it is basically saying that I give you this task. You don't. I don't need to know the answer, and then you know, maybe you will check. You will put the answer somewhere, and then I will just look for it when I have time, right? So it is sort of basically similar in programming languages. It's like you have a void outcome, but like the function return type is just void, but like you know, the program is actually perform a thing, and then you will just know um, like what happens after it done, after it is done. Yeah, so you know, sometimes you might get confused about what I'm talking about, but like you know, when you get more examples, you'll understand. Okay, so yeah, return statement. So another common is that you can have zero return, which is a void type of void return type, and then you can have like you can return something. For example, you can return 1, right? So it is returning an integer. You can return a string, question marks. That's valid as well. You can have multiple return statements, right? So for example, if x is equal to 1, then return 1, else return 0, right? I forgot the column here. Yeah, so like something like this as well. So like it does not have to have uh, you know, exactly one return statement, but you know, the function can only return once. Okay, so what does that mean? That means that when you're dealing with a function, when you do return, so in this case, if x is equal to 1, return 1, else return 0. That covers all the cases for x. So this return sentence, like either of this return sentence will be called. So whatever you do here, x is equal to 10, right? Y is equal to 20, blah blah blah. Whatever you do here, it is not being run. So return is basically means the end of the function, right? So like this is sort of like I give you an outcome, right? And then after you give the outcome, you don't actually go to do anything about it, right? So like you can have the analogy that, usually after you do the final exam, you never study that subject anymore, right? After you pass coding, after you passed, for example, physics class, you don't do physics anymore. That is understandable, because once you get the outcome, there is no need to do anything about that. All right. So yeah, that is just analogy. Does not mean that you don't have to study physics forever. So yeah, this is what happens to a programming language. It does not do unnecessary work. Okay, so yeah, that is that. Oh yeah, so in this case, if you have a return here, this will not run as well. um, as, Only when we actually comment out this return, then this will work. So yeah, that is just a tiny little example. Yeah, so in terms of more details about functions, for function name, so in terms of validability, so like if you want to have a valid function name, all you need to do is the same rule as defining a variable, right? You can have this function name as A, B, C, D, or whatever you want, right? But like in terms of readability, the name should consist of lowercase with like underscore separating them. All right, so like what does this function perform, right? Sometimes it perform get max among three elements, so you can probably say like get max, right? So like yeah, as long as you are pretty you make things obvious, uh, it is okay. So like just define a reasonable function name. Don't do like A B C D E F G, and then you just go along with like 26 functions using alphabet, and then ABC1, ABC2, ABC3. Those ones does not make any sense, and then please avoid to use that. Okay. Yeah, so like those examples like maximum 3, right? Less than or something. So yeah, that is in terms of function name. For parameter list, so you can have any number of parameters that you wish, as long as you separate them with a comma. And what does that mean? So you can go ahead and change this to, for example, x comma y comma z comma uh, a comma b comma, like you can go on and on and on and on as long as you want. And then that is the flexibility of this function in Java, in Python. And then you just separate them with a comma, then it will be fine. All right. And in terms of this idea, so formal parameters versus actual parameters. If you have studied function in any kind of language, I I guess that your instructor should have talked about this. Um, what does formal parameter mean? Formal parameter is used in a function definition. It is just there to indicate what operation needs to be done for what parameter in this function. Yeah, I'll just give you the definition without too much explaining, and you will understand it by going through the examples. And then the actual parameter is when you actually have a function call, right? For example, you do len bracket and then a list, which is called probably my list. And then you just pass in that parameter, and that is called, you know, actual parameter. Okay. And then, yeah, if you don't understand this yet, I'll give you an example. So this function is my max. This function is pretty easy. So it takes in two values, x and y, and then you can have a z. Z is equal to x if x is larger than y, else y, right? And then I just return that. So yeah, it just gives out the larger value between x and y, right? Um, and yeah, another function here is say hi, right? Was a name as a parameter, and then you just print executing say hi function, and then return hi plus name plus exclamation mark. So yeah, so this is there for function definition, and then you can have your code running here. So yeah, in terms of the order of operation, so like function is defined there, but it is not being run until you call it specifically. So what will the program flow be? So it will actually first well, yeah, I mean, it definitely compiles those two functions, right? But like it does not get executed right away. And it does not get executed until you call it, right? So like the task is already there, but like someone does not do the task until you let them to do, right? So that is a similar idea. So yeah, for example, in the program flow, we have a is equal to 6, b is equal to 9, and then you can have this result. So what this result is just to take in what the return type is, take in what is returned and then stored in result, right? And then the idea is that I pass in, I call this function, maybe, called Ray, right? And then I give you A and B, right? And then, perform a certain task and give me back a value, right? And then, this, it just go ahead, right? So my max function, right? And then this here, A and B, um, A and B are actual parameters, right? So actual parameter means when you're calling this function, what do you pass in, right? So in this case, 6 and 9, right? And then formal parameter is this x and y here. So yeah, when you call my max a and b, which a has the value 6, b has the value 9, then this x will equal to 6. Okay, then this y will equal to 9, and then you just then use 6, z equals to 6 if 6 is larger than 9, else 9, right? So this result will be z equal to 9, right? And then this entire expression is evaluated to 9, right? So my max, so like you call rate like a certain function, and then it just throw back a number in this case back to you, right? And then you, after you take this number, you assign it to a variable, and then you print this variable. The result is 9. Okay, so you understand what is going on here? Yeah. So you can have this as well. You can also have directly printed. So print say hi, right? So what will happen is you first execute this function with a parameter which is array, right? So array is the actual parameter here. Name is the formal parameter here, and then when we're trying to execute this function, it first comes here. So print say hi, executing say hi function. And then so that is what that is. And then what I do is return hi ray and then exclamation mark. Then, well, what that does is it's sort of concatenate the ray, so the string, and then return back a string. So this is basically saying print high rate exclamation mark. So I go ahead and print it. And then here is what happened. Okay. So that is, the program flow, and then, the basics about function. Okay. Uh, yeah, for function my max, x and y are formal parameter, a and b are actual parameter, and for the return statement it can return a variable as well as a expression. Typo, it should be an expression. Okay, yeah, that just does not really matter. Yeah, so for function my max x dot y, you can also do the following, right? I add this bracket so that I only want you guys to see more clearly. There is no need for this bracket. And then, yeah, I actually should write something. So my max 1 and 2, right? So yeah, if you do my max 1 and 2, then it just gives you 2. Okay. Yeah, so in terms of why it actually prints 2, because Colab has this feature. If you have a you know if your expression on the last line of that cell has a value or a return type, when you run the cell it just gives you. Okay, so yeah, this is basically print this, right? And then you run it will have the same thing. And then you can also do this print max. My max is equal to 2, and then that will give you true. So that is also an indicator that I call my max. It will throw me back a value, and then this value is whatever is returned in the function, and then equal to 2. Okay, so yeah, in this case, my max is just evaluates to 2, and yeah, also you can just pass in literals, and by I mean literals, I mean like, so maybe constant values, right? And then maybe string directly without actually assigning it into any kind of variable, right? So like it does not have to be a variable as long as it has the value in it. But we usually pass in variables because that will make our code more clear. All right, is that good enough? The explanation. Yeah, so I am just gonna pause here for a bit, and then probably wait for 3 minutes and see if you guys have any questions. Yeah, I mean this functions is pretty important idea, and then you have to understand it pretty well, so that you do like any kind of stuff after this, right? Because yeah, when we talk about classes, then we definitely have a lot of functions, because most of the yeah, I would say most of the class are made of functions. So yeah, we have to be like really careful about this. So yeah, if there are any questions or any concerns, I am gonna wait until 10:55. Okay, and then I'll give you some time, and then maybe a little bit of a break as well. Okay. So yeah, it seems like everyone is pretty happy about this idea of function. All right. So yeah, so I will just get into the next topic. Write documentation for a function, right? So like, when you try to write a function, you will explain to people what it does, right? Um, because this is a black box, you will have to tell what the user, what do you expect from the user, and what is the outcome, right? So like if you are telling someone that there is a machine out there, right? So like you'll have to like sort of describe what materials in there, and then what can you get out from that machine, right? So for example, if you have a vending machine, right? Vending machine is just a 自动售卖机, right? You're expected to put in some number, and then you just choose what you want, and then the output is, the food that you want, right? Maybe some snacks, maybe a bottle of Coke or something, right? So that is the same for a function, and then you have to explain what that is. And then the way you write this is you do the comments, okay? And then there is a specific type of comments for functions. So if you do like triple single quote, which just means like this is just a chunk of uh, chunk of code, right? In Python, it's just indicated by three single quotes. But yeah, right after the definition of the function, if you do something like this, and then you can do help mymax. So help on function mymax in module main, right? And you can just ignore that. Yeah, those are printed out, right? So this is the function name. This is your function definition. And then this is like just a brief sentence to explain what this function does. And then just this is just what is returned, right? And then you can also do is after I comment out this, you can have this mymax.doc. Okay, we are gonna learn this more when we actually do classes and those. But here is what it is. So if you do class underscore underscore, yeah, this is just two underscores. Okay, there's nothing special with it. This looks like a special format, but it is a special format, and it is just a naming convention of Python for a class. And I am just going to talk about it later when we're talking about like classes and objects. But yeah, if you do mymax and then dot underscore underscore doc, you can have this. So this is basically whatever you write in this definition, the comments. Okay, and then if you are actually curious about that, in fact, I am curious about that. You can do this. Help on built-in function, then a module built-ins. Then object slash returns the number of items in a container. Pretty self-explanatory. It is what you expect from a len function, right? So you do doc as well. And then no Python documentation. Okay, yeah, there's no documentation on this. Yeah, you can help with string. There's this string class, right? So yeah, if you're actually curious, you can explore it yourself. But yeah, this is how you write a comment for how you write a documentation for a function. Okay, so yeah, in terms of some sort of project or stuff, it is always good to write comments, right? When someone else is reading your code, um, he actually needs to know what is going on, right? And then you might think your code is self-explanatory, but it's actually not, right? Like no matter how simple it is, as long as it is not return 1 plus 1 is equal to 2, then you need to sort of write some kind of documentation, right? And then just for easiness of yourself and then whoever is reading it. Okay, so yeah, enough about that. You can have multiple return values, and this is a pretty you know luxury thing, I would say. Yeah, so in language Java, C, C++, you don't normally have something like this. So like you only return a single stuff. That is the intuition if you have programmed before. But in Python, it that situation can vary. And so look at this function, sum and average. What you're taking in is a list. And then you can have sum is equal to 0, and then count is equal to 0. And then for E in list, so for each element in the list, this thing is I want to elaborate upon more. So if you are not sure about a specific function, then you can do help, right? You're asking for help. So yeah, help is instance. So is instance, take an object, take a class or a tuple, then it returns whether an object is an instance of a class or a subclass thereof. So it's basically saying that is instance e comma int will check if e is a integer. Okay, so yeah, that is pretty useful. And then that is you can actually do something related to that with like user inputs and other kind of stuff like this. So yeah, is instance, and then you can check if e is a float. Then yeah, you can check a lot of stuff. After you know how to define your own object, then or your own class, then you can have more fun with that. Okay, but yeah, this is basically saying that if this is an instance of int, this is an instance of float, and then like either of those are true because this is or, right? So if either of those are true, then count plus equals to 1 means that there is um, larger one more number in this list, right? And then sum is plus equal to e, then you just put sum, you just sum up every element. And here you have this statement, and this is pretty strange. So you have return sum, right? So sum, you can expect that. So this is just a sum of the entire list. And then you can also get sum comma count, sum divided by count. And sum divided by count is just average, right? Uh, yeah, so that is average, and then you can actually return both of those variables at the same time. And what does that actually mean? What does that actually happen in the program? What does that actually happen is that if you do comma, return something, comma something, then it is basically actually make it into a tuple. So that is sort of like a packing step, right? And then okay, you can have like this my list there, and then you can have TP. Yeah, this is just a number, random variable called maybe tuple, and then just calls the sum and average on my list. And so this list is sort of passed into the function. And then if you print the outcome, you can see this is a tuple, right? If you print type TP, then this is a class tuple. So it basically means that it actually packs it for you. So I mean, the maybe in the deep down level of this Python language, it is still the fact that we can only return one thing, but it does the packing for you so that it makes you think that you can return multiple stuff. But yeah, I mean, I'm not gonna make any comments on that. I don't know whether you understand it as you know it only returns one thing or it actually returns multiple things. But it actually does not matter as long as you know how to deal with it. You just take a tuple and then you assign to that to a variable, and then it is a tuple. That is it. Okay, end of the and end of the story. That is the problem that we're dealing with. Okay, so that is multiple return values. Recursion, that is a very scary topic, and I am not yet ready to fully explain you on this, but I will basically explain you what is going on, right? But like, there's nothing too much about it after my explanation. So yeah, recursion is means that a function that calls itself. So it is basically saying that within a specific task, you do another task, and then those are like sort of nested. Okay, and then the idea is, for example, if you have a mask sequence look like this, so f0 is 1, f1 is 4, then fm plus 2 is equal to 2 times m plus 1 plus fn, right? And then you're basically sometimes calling f10, and then it actually goes into a recursion, right? So basically it says fn is fn. I might actually make it wrong. So yeah, in terms of this, this is just fn. Yeah, sorry about this. I might type it something wrong. So it's 2 times fm minus 1 plus m minus 2, right? Yeah, because if this is the case, the recursion is not never gonna end, right? Because yeah, sort of the idea is sort of like this. But yeah, the other idea is, think about it. If you replace m plus 2 with n, then m plus 1 is m minus 1, right? And then m minus 2 is fn. So actually, this those two are equivalent to each other. Yeah, so like, if you're really into math, then you can actually think about it. But yeah, that is a sample recursion function. And when we talked about recursion, Fibonacci is always the first thing that we think about. And I believe I have introduced you this loop way of dealing Fibonacci. And I'll just make a comment here that the loop way is the most efficient way of Fibonacci. And this idea is called dynamic programming. And then I am not going to talk a lot too much about it because it is a very difficult topic to mention for starters. But here, recursion tree. So I am just gonna show you a recursion tree. So what is a recursion tree? It means that, so for example, after you call, I will just comment this. In this recursion tree, fib, I believe 6. Oops. Fib 6, fib 5. Okay, so fib 5. When we call print fib 5, what will happen? Think about it. It is a recursion tree. So it is like if n is equal to 1, return 1. If n is equal to 2, return 2. And then other than that, return fib n minus 1 plus n minus 2. And then for sure, the input is specified that is a number larger than 0. Okay, so yeah. So yeah, back on topic. What will happen if we call fib 5? So if we do this function, then fib 5, is n equal to 1? No. Is n equal to 2? No. Then we are going to return the result of fib n minus 1. What is fib n minus 1? Right? So in this case, n is 5. N minus 1 is 4. So we're going to return fib 4 plus, what is this? Fib 3, right? So this is the recursion tree. If you have fib 5, then you're going to return fib 4 and fib 3, right? Like you are needs results for those to calculate fib 5, right? Correct? So to calculate fib 4, you will have fib 3. You will need fib 3 and fib 2, right? And then that is this continuous of recursion tree. And then if you keep calling this and this, and then you will finally you will have fib 3. Yeah. In terms of this, I will make a little bit change on the program I wrote. But yeah, it is basically doing the same thing, except that it has different starting value than I am. Okay. Yeah. So fib 0 is 0, and then fib 1 is 1, and then fib 2 is just 1 plus 0. So yeah, that is the same thing. And then if you call fib 3, and then you have fib 1 and fib 2, right? And then fib 1 is a thing called base case. What do I mean by base case? By base case, I mean, in a typical recursion, there is those are called base case. So you're basically having a bunch of if statement and saying that if n is equal to something, then you do what, right? And then for example, if n is equal to 0, so this means that the first term is 0, right? Fib 0 is 0, right? And else if fib 1, right? And else if fib 1, what is fib 1? Then fib 1 is just 1, right? So those two cases are called base case for this fib function. Okay, and then after those two base cases, there is a recursion call, right? This recursion call is just basically means that you call the function, you call yourself with a different parameter, right? And then you can have fib 1, right? And then fib 2 is just basically fib 0 plus fib 1 plus fib 0. And then after all of those, reaching the base case here, then what you're going to do is you calculate each of them, right? So fib 1 and fib 0 gives you the answer for fib 2. Fib 2 is 1, right? And then fib 2 is right now 1, fib 1 is 1 here, then you can get fib 3, right? And then for this case here as well, fib 1, fib 0, you get fib 2, and then you get fib 4, right? And then on the right, you're basically doing the same thing. Okay, so that is a recursion tree. And I am actually having a difficult time of yeah, I'm not sure whether this is a good time to introduce dynamic programming, but I will just make it short. So I'll give you an idea of what dynamic programming is. So when you do this recursion tree, did you find any problem with it? Stare at it, and you can sort of give out some conclusion, and this is a question. This is a time that I ask for you guys for some input. When you look at this recursion tree, is there something special with it, or is there something problematic with it? And I want you, if you guys have any comments or worries, it doesn't have to be like really sophisticated, as long as you just give me your findings of this recursion tree. Are there any comments on this? Any sorts of idea? Any? Yeah, like it could be anything. Yeah, I'll wait until like 11:18, and then I'll explain what is happening and what is wrong with this recursion tree. Like there is definitely something wrong with this recursion tree, and yeah, I'm not saying those recursion tree is not correct. I am just saying that maybe sometimes you are doing repeated stuff, and sometimes you're doing something that is not very efficient. Any thoughts? Speak now. Yeah, any thoughts and comments? Interesting findings? No one? Yeah, I'll wait 10 more seconds before I reveal the answer. I personally hate being reviewed the answer, so I hope you guys, try to speak as much as possible. All right. Since no one wants to answer it, when you look at this recursion tree, what do you find fib 2? Fib 2 is here, 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 right? And then fib 3, when you look at fib 3, so you have a tree here, and then you have a tree here, right? And then for fib 5 already, we have those repeated trees, right? Like on this branch you are calculating fib 3, but on this branch you are also calculating fib 3, and this is a huge waste of time. And then as you would turn out, this tree will grow exponentially. Okay, so if you are having this fib number of like 6, 7, 8, 10, or if you have like fib larger number, then the exponential tree will grow, the recursion tree will grow larger and larger and larger. And if I do a little experiment here, so what I was doing is I print fib 1 to 10, and then easy peasy, not a big deal. 20. Okay, fair enough. Not bad, right? So like you can see once I entered it, then it is good. What about this? Fib 31. Okay, under here it says it takes 1 second. I'm assuming this collab is hosted on a pretty fast computer. So when you do fib 30, then the number is already like this. The critical point comes when fib 40. When you try to run this, you can actually see, uh, you know, this is increasing. If you see lower bar, there's so many fib functions in here. So this is like calling it recursively. It is very inefficient. It is executing it slowly. And then that is only for 40, right? Imagine you have to deal with like 100 or something like that. You have to wait here, you know, you can even take a nap. Um, and then when you get up, there is no progress on this program. So that is something that we don't want when you when you actually try to run some program. You actually want it to make progress, right? So yeah, one technique that we will use is called dynamic programming. The idea is just to store each of the value, each of the fibs in a list or something like that, so that you don't have to go through the recursion tree to get the answer. But that is the idea of dynamic programming. I am not gonna go very deep into that. If you are interested, go research it yourself, or you can do come ask me. I am pretty happy to discuss those ideas with you. And then just to make a comment that dynamic programming is very important in terms of like software developer. So yeah, this is a very important algorithm. You will see it in interviews, coding contests, everywhere. Okay, so that is a comment that I'm gonna make, and I am just gonna continue my lecture here. So that is a brief introduction. I'm not gonna say brief because I actually talked about it pretty in a pretty detailed way, but that is usually how you deal with recursion. Okay. Yeah, and I expect you to only know this aspect of recursion, and that should be enough. Okay, let's back on the topic of function. So there is in terms of parameters, there's more stuff to cover. So there is this thing called keyword parameter, or keyword argument. Um, so if you pass in arguments in terms of position, they are called positional arguments. And if you pass in arguments using argument name, then it is called keyword argument. And what does that mean really? So let's look at this function. So basically, you have a function that calculates the circumference of maybe a rectangle, right? So you have width and you have height. And then you just print the width, print the height, and then you just return 2 times width plus height. So that is self-explanatory and pretty easy. So what I mean by positional argument is that when you call a function, you put the parameters in position like this. So 3 comma 4, right? And then what does the interpreter think? The interpreter think that 3 is the value for width, and then 4 is the value for height. And then if you run this function with circum 3 and 4, then Here, look at this. So width is 3, height is 4, and then you know the answer is 14, right? What you can also do is something like this. You can specify which I would say which parameter is equal to what, and this is called keyword arguments. So you can say width is equal to 3, and then height is equal to 4. And you might think that this is pretty redundant. I can just pass in 3, 4 without any trouble. Why do I have to bother and type those parameter names, right? And what I can tell you is that with this feature, we can ignore the order of arguments, right? So on here, you can see print circum height is equal to 4, width is equal to 3, and then the third run of this function, you still have width is equal to 3 and height is equal to 4. But the order of you passing in the argument is different. But the result is the same, thanks to keyword arguments. And beyond that, you can sometimes use keyword argument and sometimes use positional argument. In this case here, print circum 3, height is equal to 4. Then, 3 is automatically passed in width, and then height equal to 4 is already automatically passed in to height. But what you cannot do is the following. So if you try to print circum width is equal to 3, I mean, width is always equal to 3. But like if you want to try to pass in width is equal to 3, but you are following a 4, which this is a positional argument, and this is a keyword argument. This is not allowed. Okay, so positional argument follows keyword argument. Okay, so positional argument is not allowed to follow the keyword argument. What that means is that if you have this keyword argument like this, so height is equal to 4, then it will always be the last few arguments that you pass in, right? You can do okay. Yeah, what you can do here is you only pass in the last few arguments using keyword arguments, and you will always put positional arguments before the keyword arguments. So that is the comment that I want to make. And then here, but positional argument must be before the keyword argument. If you don't do that, it will give you an error. But I mean, if you're happy with positional arguments all the way, then I mean, feel free to use it. I am just here to tell you what is allowed and what is not allowed. But you have your own style of programming. I have my own style of programming. The style is different. If the style is the same, you will be called plagiarism. Yeah, for programming, it's really easy to call plagiarism. So don't try to do that. Because yeah, in my class there is like quite a lot of people are being caught, especially in today's situation. Not in my class, but like in other classes. Yeah, but like yeah. So one comment I'm gonna make is that everyone has its own his own style of programming. Don't try to copy someone else's code because they have different style of programming, and this is not your style. And then when you actually write your code and then you copy and paste someone else's code on there,
it is really easy to tell. Okay, like don't feel like you can get away with it. It is really easy to tell, especially with those profs who actually have like so many years of programming experience. It is really easy to tell anything strange in there. So yeah, that is some other issue. Yeah, so back into the topic, there is a saying called default parameter value. It is basically saying that you, if you don't pass in any kind of value to this parameter, then in default, this parameter is equal to something. Okay. So